This is Ms. Wiles, and in this video you will see 4 problems worked out, factoring for numbers 1, 3, and 4, and solving for all of them. I would encourage you to attempt these on your own and then pause and restart and everything in the video as you need to check your methods. There are some hints here for the first 3, and they were given in class for the quiz. So number 1 and the first hint is that the GCF of this equation is 2p. Now, what the GCF means is the greatest common factor. It is the greatest number and variable that is a factor of each of these terms. You're looking at the 18 and the 14, and what's the highest factor that they have in common, and that's 2. And the p squared and the p in the 2 terms, and what is the highest, the greatest common factor that they have in common, and that's the p itself. Again, the 18 and the 14, that's what gives you the 2. You want to make sure that you have the greatest common factor, because that's going to affect what is left inside the parentheses. And you can always check to see what's left, to see if they have any common factors at all, to make sure that you have actually factored out the greatest common factor. What we have left when we factor 2p out of 18p squared is 9p, because 2 times 9 is 18, and p times p is p squared. What we have left when we factor 2p out of negative or minus 14p is negative or minus 7, because 2 times negative 7 is 14, and p times 1, in effect, is p. This equals 0. At this point, we have factored completely this equation. It is factored. 2p times 9p minus 7 are its factors. And the 9 and the 7, since they have nothing in common here, I know that I have done everything that I possibly can. Now these factors give me my solutions of 0 and 7 over 9. Because with the 2p, p is 0, that's going to make that 0. And with the 9p minus 7, we have the opposite of negative 7, which is 7 over 9. And these are my solutions. Could you find those with the calculator? Certainly you could. And that's for another video. Now we'll go on to number 2. Number 2, we have 5x squared plus 30 equals 0. And the hint was to move the 30 to the other side. So if you took that hint, you would have 5x squared equals negative 30. At that point, since the other part of the hint was to solve with square roots, you would divide both sides by 5 so that you could end up with x squared on one side. This would cancel out, and we'd have x squared equals negative 6. We take the square root of both sides. The square root of x squared equals plus or minus the square root of negative 6. The square root of x squared is x. And the solution here with plus or minus negative 6, the negative under the square root sign would be I, and we should have square root of 6 here. Actually, if I look back at my instructions, yes, you should have factored 1, 3, and 4. Now the reason I said don't factor 2 is because with these kinds of solutions, we do not have real number factors. So that is why you only had to find the solutions for number 2. Moving on, the third problem. Now the third problem is a trinomial, and it is a trinomial with a leading coefficient of 1. With a trinomial with a leading coefficient of 1, I want to find 2 numbers that, and actually this works for any of them. Let me go back. I don't want that line there yet. Where the 2 numbers that I'm looking for, they have, when I multiply them, I want to get a times c. And here a is 1, b is 15, and c is 36. So I want to find 2 numbers that if I multiply them, I get 36. And if I add them, I get 15. So this is multiply, and this is add. And so I think about all the factors of 36. It can't be 36 times 1, because if I add those, that's 37. So that doesn't work. 2 times 18 If I add those, if I multiply them, I get 36, but if I add them, I get 20, so that's not it. 3 times 12. If I multiply that, I get 36. If I add that, I get 15, and I'm like, yes. And if my leading coefficient is 1, then I can go directly from that into my factors of x plus 3 and x plus 12, noticing that 3 times 12 is 36. And 3 plus 12 is 15. And all of this fits in together very nicely. These are my factors, and my solutions from those factors are -3 and -12. Now, could those solutions be found in the calculator, in the table, if I were just to put this equation into y equals? Yes, they could easily be found by looking at the graph if you change your window, or by looking in the table. And in the table, you would see that when x is -3, y is 0, and when x is -12, y is 0. Those are all indications that you found your solutions, and then you can work from your solutions back into your factors. Number 4. Number 4 is also a trinomial. However, with number 4, a is not 1. A is 6, b is 19, and c is -7. Therefore, I want to find two numbers that if I multiply them, I will get a times c, which is 6 times -7, which is -42. If I add them, I will get b, which is 19. So I can already tell that one of my numbers is going to be positive, and one of my numbers is going to be negative. That's the only way that I can multiply two numbers and get a negative. But when I add them, I'm going to get 19. When I add them getting 19, that really tells me that the highest number is going to be positive. So I can look at 42 and -1, but when I add those, I get 41. So those aren't the right factors. I can then try the 2, and I have 21 times -2. And when I add those, the 21 plus -2, I get 19, and I have found the two numbers that I'm looking for. Now, if I'm doing this, since the leading coefficient is not 1, these are not my factors, but I can use them to determine what they are. So I'm going to go with my 6n squared. This 21 and this -2 tells me how to split this middle term up. And I'm going to hold off on that for a minute, leave some space, and put a -7 out here. I've got a 21n and a -2n. Because of that, I look at the relationship between these numbers and this 6 and this 7. The 21 has a better relationship with the 7. They have something in common. They have a common factor of 7. The 6 does not have anything in common with the 21. Well, it kind of does. It has a 3 in common. But the 2 has nothing in common with the 7, so it really needs to be paired over here with the 6. So this is how I split it up, and I look at these two and I see what's happening. I look at the first pair, the 6 and the -2, and what they have in common is 2. If this number is positive, I want to keep this positive. So what they have in common is 2 and n. What they have left after I factor that greatest common factor of those two out is 3n and -1. If I look at the 21 and the -7, they have a 7 in common. Because I want the 3n -1, knowing this method, to be the same as it is in the first pair, that's going to help me decide whether this 7 is going to be a +7 or a -7. And if I know that I'm going from 21n to this 7 times 3n, that's going to be a plus. What that helps me do is bring these two that are left outside of the parentheses together as one factor of 2n plus 7, and the other factor is 3n -1. And my solutions are -7 halves and 1/3. Now, can I find those solutions in the calculator? Yes, I can. And if I'm very careful, I can find those exact solutions. But if not, I'll find something that's very close, very similar. If you're told that it can be factored, then you should know that you will find either a whole number or a fraction as a solution. You will not use a decimal, because even here you might find that the solution is negative 3.5. However, you will not ever have a decimal as one of the numbers in your factor. So to have n plus 3.5 would not be a correct factor. You would need to change that negative 3.5 into the negative 7/2, and then you will have, I don't know why I drew that arrow over here. This arrow doesn't go here, it goes right over here. But change that negative 3/2 into negative 7/2, and you've got your other factor. Well, those are four very nice equations, four different methods that can be used to solve quadratic equations, and that's all I have to say about that.